All right, welcome back. So now let's look at the horizontal and oblique asymptotes. Okay, so let's talk about how to find them and then we'll actually put it into practice. So to find the possible horizontal or the obliques, we're going to compare the degrees of the numerator and the denominator. So there are going to be three cases which will be considered. Because one of three things is going to happen. So the first one is when the degree of the numerator is less than the degree of the denominator. So the denominator has the bigger exponent. So in that case, there is a horizontal asymptote guaranteed at y equals 0 every single time this case happens. All right, case number 2 is instead of them, the numerator being less than, now the degrees are equal. So there's still a horizontal asymptote, and it's going to be the ratio of the leading coefficients. Okay, and then the last case, which you probably guess what it is when the numerator has the bigger degree and the denominator has the smaller one. So in this case, you kind of have to pay a little bit more attention because the numerator is going to be the bigger degree, but only by 1 degree. So it's only 1 degree higher than the denominator. So in that case, the graph has an oblique asymptote. If it's 2 degrees or more, then there's no oblique and there's no horizontal asymptote. So it's really specific on how much larger it can get. Not true for case 1. The denominator can be as many degrees higher than the numerators at once. There's always going to be an asymptote at 0. But for the numerator, if it's 1 degree higher than the denominator, then you've got an oblique. So to find it, you're going to divide the denominator into the numerator, like you're actually going to do the division. And a new function will be created and will have the form f of x equals ax plus b plus r of x over q of x. So you still kind of have a rational function, but you're going to have these other two terms sitting in front of it. And so the oblique asymptote is at y equals these front two terms, that ax plus b. So that's why they call it a slant asymptote, because your asymptote is actually a linear function. It's a line. Okay. So let's see if we can figure out where they are. All right, so we're going to find any asymptotes. So for example A, the vertical asymptotes are right at 0 and positive 5. The horizontal asymptote, well, the denominator has the bigger degree. The denominator's degree is 2, the numerator's degree is 0. So that means you automatically have an asymptote at y equals 0. Okay, so it sounds kind of tricky or difficult when they say, hey, find all the asymptotes, but it's really not. You just kind of have to look at it for the most part. All right, part B, you have vertical asymptotes at 0 and 5. The degree of the numerator is 2, which is the same degree of the denominator, so now it's a tie. So when it's a tie, when they're equal, the horizontal asymptote is the ratio of the leading coefficients. So if you kind of multiplied it out, your leading coefficient on the top is a 4. The the leading coefficient underneath is a 1. Leading coefficients are attached, or the coefficients that go with the highest power, in case you're wondering. So there's your ratio, 4/1. So there's your horizontal asymptote. Okay, part C, let's do a little bit of work here. Because you can factor the denominator into x squared plus 1, 3x squared minus 4. So there are some values of x that make the denominator 0. So if you solve the denominator for 0, that first term doesn't do anything, but this back one does. If you solved it for x, x is going to equal plus or minus 2√3 over 3. Now the horizontal asymptote, the degrees are equal again, so just take their coefficients, the 2 and the 3, and there's your ratio. All right, let's skip over part D for a second. Let's go on to part E. So part E, there's a vertical asymptote at -2. But if you notice, the degree of the numerator is a 3. The degree of the denominator is a 1. So the numerator is bigger, but it's by 2. So in that case, if it's 2 or more, there is no horizontal and there's no oblique. So there's no horizontal asymptote and there's no oblique asymptote. Okay, so let's work our way back over to D. This is the the tougher one, because if you notice, the degree of the numerator is a 2, the degree of the denominator is a 1. So it's bigger on top, but only by that 1 degree. So now you have to actually divide. So it doesn't matter how you do it. There are 2 ways. You can either use long division and just go ahead and divide it out that way, or you can use synthetic division, and it doesn't matter to me which way you go. Personally, I like synthetic division because it's usually faster, but it's not going to matter which method you choose. Okay, so figure out what makes the denominator 0, which would be a 1. I'm going to stick that here. And then I'm going to take my coefficients of the numerator and I'm going to write them here, just leaving some space in between. So this is the setup for that synthetic division, which is weird because it doesn't look like it's like, really, that's division. Yep. Okay, so the process is whatever this first number is here, you're just going to drop it down below the line. Doesn't matter if it's a 1, a 17, 108, just drop it down. Once you drop it, you're going to take this number, multiply it to this number over here inside that little box thing. So 1 times 1 is 1, and you're going to write it in the next column. So now just perform the arithmetic. -3 plus 1 is -2. And then just repeat that process until you get all the way down to the end. So -2 times 1 is -2. -5 minus 2 is -7. So what we've just done is we've done the division. So this function, this g of x, you've turned it into, the numbers down here are your coefficients, and it's always going to start out as 1 degree less than the actual numerator. So the degree of the numerator is a 2, so that means the degree of the answer, or the result, is a 1. So 1x the first minus 2. And then this last number here, that's your remainder. So 7, and then you're going to stick it over what you just divided by. So I've got x minus 2 minus 7 over x minus 1. So that oblique asymptote is in the linear part of the answer. So it's like you're going to cover up the fraction that you just ended up with and just write the x minus 2. Or y equals x minus 2. And that's how you're going to get your oblique asymptote. The vertical asymptote, that's just going to be right at 1. Okay, so if you don't like the synthetic division, that's not going to hurt my feelings. Just use the long division and do it that way too, or instead. Okay, that's going to do it for section 4.2. So in the next one, we'll do 4.3 and looking at some of the graphs.